This is section 6.6, and today we're just going to use proportions to help us solve for sides of triangles. Mainly, these theorems have to do with parallel lines in a triangle. So we're talking about a triangle being set up like this, and then one of the sides being parallel, and then we're going to set up proportions within there. So the triangle proportionality theorem just says if a line parallel to one side of a triangle intersects the other two sides, then it divides these sides proportionally, okay? So what it's trying to say to you is that if TU is parallel to QS, then some stuff happens. The way that it chunks the triangle up ends up putting it into a proportion. So RT, this one out here, over TQ, is the same as RU over US. So the way that it breaks up the sides kind of creates them into a proportion. The converse is also true. If a line divides the two sides proportionally, then it's parallel. So if you know that these guys are in proportion, then it tells you that those are parallel to each other. So if this stuff were to be true, then TU is parallel to QS, okay? So just to do a couple of examples with that, you're going to find it's just as easy as the other stuff we were doing in 6.6 with proportions. You just have to set them up first. So in the diagram, we tell you that these are parallel. We tell you that RS is 4, ST, that's a T, is 6, and then QU is 9. So what's the length of RQ? We'll put an X there. So I'm just going to go X over 9 equals 4 over 6. The sides that it cut, that the parallel line cut, have to be in proportion. So then I can just solve. 9 times 4 is 36, and 6 times X is 6X. Divide by 6, and I get my answer. The next one, same concept. They're just doing an example here of a shoe rack. So there's my triangle, there's my parallel line. They're telling you that AB is 33, BC is 27, CD is 44, and we're looking for, DE is 25. Is the middle shelf parallel? So what you're trying to see is if these two proportions are equal to each other. What was this one? DE was 25. So you're trying to see if these are the same. And if you reduce these, 27 over 33, let me grab my calculator quick. 27 over 33 ends up to be about 0.81 or 0.82. And 44 divided by 25 is 1.76. So this would be no. It's not parallel since the sides did not stay in proportion. On the next page, we have one more theorem here that talks about, again, some more parallel lines, just talking about if you had more than one parallel line. So if 3 intersect 2 transversals, so parallel are up and down, my transversals are going this way, then they divide the transversals proportionally. So all of these chunks just became a proportion. It's almost like having a giant triangle in there. So what that means is your proportion of UW, this guy, to WY, kind of the same thing we were doing on the other side, is the same as VX to XZ. So kind of just taking those pieces, those chunks, and then setting up a proportion together. So in order to do this guy, to find AB, I'll put an X there, and I'll just go 15 to 18 is 16 to X. And we'll solve that. So 18 times 16, sorry while I cheat on my calculator, and then 15 times X, and then divide by 15. So X is 19.2. Okay? One more theorem, just a different way that you can write proportions. This one is in a triangle, and if you have a bisector, an angle bisector, so you just cut this angle in half, that means that these sides are in proportion to each other, okay? So what that means is that AD, the end, over DB, the other end, is the same as the proportion of CA to CB, the two sides, okay? So one end with one end, and then a side with a side. So here I've got this lovely picture, and we're going to solve for X. We're going to solve for X right there. So I'm going to set up my proportion, and it's going to be RQ. Here's my angle bisector, so there's my chunk, over QP. Whoops, QP. And then I'm going to have RS over PS. So RQ, I'm not sure how long that is. I know the whole thing is 15. And so 15 minus X could go right here. QP is 7. RS is X. And PS is 13. So now we just have some math to do. A little bit of solving. So 7 times X is 7X. When I do this, I need to make sure that the 13 stays outside, so I distribute that. So 13 times 15 is 195, going like that, and then minus 13x. I'll add 13 over, and then I'll divide 195 by 20, and I'll get x is about 9.75. Okay? And that x is right there. That's RS. That's what we were looking for. So today is just a bunch of different theorems about ways to set up proportions. This one, you just use the two outsides, so the two little pieces that got cut against the side. These ones are the two pieces to the two pieces. And then the other page was the same thing with the triangle with the third parallel side, that this is in proportion, sorry, that these guys are in proportion once it got cut by a parallel line.